Hey, there we go. What's up, everybody? Welcome back to another live stream from the Scalar Learning channel. And today's the day before the day, because tomorrow you guys are taking the SAT, whether you're an international student or a domestic student, a U.S. student. And first of all, I want to wish you guys all the best of luck tomorrow. And if you're here, what that probably means is you're serious about this. You've been doing your prep, you're studying hard, you're really going for it. I tried to pick a time that would work for both U.S. kids and international kids, so that's why I started so early today. And hopefully, we can wrap up in around an hour and get through all this stuff. So what I wanted to start with today was essentially like when I look at tests, the officially released tests over the last couple of years, it's interesting because I've seen little trends of new types of problems that are more prevalent now than before. And so, this is me guessing, right? But I do have a feeling that since I'm seeing these trends and I'm seeing more of like certain types of problems popping up on the later versions, and later versions, I mean 2021, 2022, 2023. I think that's a good indication of what might show up in terms of like the nuanced, like unique type of problems. Obviously, there's a lot of problems that I'm not going to cover right now that of course are going to be on there, right? Your typical circle problems, your systems of equations, etc. But those kind of ones have been around for a long time. So I'm not going to necessarily focus on those. If you've done your prep, you've hit all the practice tests, the official ones, you've seen those, you've done those. Here I want to focus on the ones that are a little funky, a little different, that have been showing up more recently. So hopefully this will give you a good idea of what you'll see tomorrow and really get you prepared for the tough problems, okay? And thank you guys, by the way, for all the love. I see some comments. If you guys have had hadn't had a chance yet, if you could like the video as well, that really helps the algorithm. So if you could click the like button, massive. And let me see if you got any questions. People are saying good luck. 7 p.m. in Eastern Europe. Awesome. Don't be scared. Don't be scared. Okay. We got some digital folks in Europe, it looks like, and maybe other places. Okay, cool. All right. So here we go. Now, one of the things that I've seen a lot lately on the release practice tests are these interesting systems of inequalities. Now, these have been there before, so don't get me wrong, they're not brand new, but I have been seeing them more, and I've been seeing, in my opinion, tougher versions. Now, this is the one version, okay, and a simpler one, but typically what I say, and this is a good example, when you see a system of inequalities, I immediately go plug and chug. I'm immediately saying, hey, which one is a solution? So I'm gonna check them in all these equations. I'm gonna plug 1 in, right? Is 1 greater than 4? No, right? When I plug 1. So 1 is immediately out. Let me annotate a little bit here. And oops. So that one's gone. Then I plug in -2. Is -2 greater than -8? Yes. What about here? Is -2 less than 2? No, that one's out, right? So then you see we got -3 greater than 12 for C. No, already out. You see what I mean? And then we have 4 is greater than -16. Yes. 4 is less than, wait, I must have made a mistake here. Hold on, let me back up. Because that one doesn't work either, because 4 is not less than 4. Hold on. Let me see if I made a mistake. 1 is greater than 4. Yep. That one's out. All right, now I'm messing this up. Sorry. -2 is greater than -8. True. -2 is... Oh, yeah, it is B. Sorry. Because -2 is greater than -8. -2 is less than +2 because you flip it. So anyways, that's what I do, a little plug and chug. Now, I included a second example here in this next problem. This is a tougher one, and it's funny because this is from, I believe, March 2023. And I got this one wrong, I think, twice, because it's like you have to look what you have to do. They made it very hard. Like to check A, I have 3 different coordinate pairs to plug in, etc. If I remember correctly, C was the right answer. But it's that same idea, right? You're gonna run through the choices and be like, hey, does 3 -2 work in both equations? Does 0, 2 work in both, and 4, -3 in both, right? And it's hard because you have to run through all the options and kind of eliminate. But anyways, that's what I do. I go straight that plug and chug method. Okay, let's move on to the next type of problems that I've seen so many of these. It's crazy. Now, obviously, it's not just like generally quadratic formula. Obviously, quadratics are a big part of the test, but it's formatted in this very particular way. And I've seen, you'll see, I put a bunch of examples. We won't do every one, but they do this interesting thing where they're like, the solutions are n plus this and n minus this. So it's not saying quadratic formula, but this obviously is reminiscent of the quadratic formula, right? Which is negative b plus or minus square root of b squared minus 4ac all over 2a, right? And so you look at something like this, you see a radical, and you should immediately think, well, I'm solving the quadratic, I'm getting a radical. Okay, probably should be using the quadratic formula. It's probably not solvable without it, right? So you're going to go, excuse me, into that format where we got a, b, and c. So it's negative b plus or minus square root of b squared, which is 4 minus 4. A is 1, and c is negative 1, like so, over 2a. 2 is, 1, a is 1, so 2 times that is 2. And then you get 2 plus or minus, the negatives cancel out, and then it's 4 plus 4, which is 8 over 2. Okay, so it still doesn't look like this, but you just got to get it here, and then just keep simplifying, and you'll see, right? Oh, 8 can be 2 rad 2 if you simplify it. Now I can divide everything by 2, and I get 1 plus or minus rad 2. Look, now it resembles this format, right? Now you can see n is 1, k is 2, 1 plus 2 is 3. So my point is this is kind of the standpoint you work at it from, is you just say, hey, probably using the quadratic formula. Let me take a crack at it, plug and chug, and see where it gets you. And then it'll make sense. Here's another example, right? So in this one, they're like, hey, what is m plus k? You're like, what are they talking about? Oh, it's a quadratic, probably quadratic formula. I'll do this one quickly. I'll show you the next ones. I'll just show you, and I won't do them. But just to see, so you can see how many of these keep showing up. We got negative b plus or minus square root of b squared minus 4ac all over 2a. 2 times 1 is 2. And then that's negative 4 times negative 9 is 36. 16 plus 36 is 52. So we have 4 plus or minus 52 over 2. Now this one you can simplify, and you can get rid of the denominator. But look at how they presented it. They presented it with a 2 underneath. That means you don't want to simplify it. You want to leave it alone as is. So this is the correct format. So it's just going to be 4 plus 52. That's m plus k, and that's 56. All right, let's move on to the next one. Again, same idea. I'm not going to go through this one, but it's the same idea, right? You see a radical. Oh, I probably should use the quadratic formula. And this is one more example. Same exact thing. Use the quadratic formula. Simplify until you get 5 plus square root of something, and that's how you'll get n. Okay, the next thing that's been shown up a ton that didn't used to really show up at all are geometric proofs. So I'm going to show you kind of like a variety of a few of these. And yeah, so somebody brought up circle questions, RUPS. I actually have some circle problems here. And then after we do these sort of predictions of what I think is going to be on there, especially tomorrow prevalent, that's like kind of unique, I'm also going to go through the critical formula. So we're going to talk about the circle formula as well, and all the important stuff. Okay, so don't worry about that. Now, we get to something like this, and what are they asking? They're saying, which of the following is sufficient to prove that these two triangles are congruent? So what this tells you is you need to know your congruence theorems. You also need to know your similarity theorems for triangles. Congruence theorems, we have angle, side, angle, 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 side, side, angle, side, 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 and hypotenuse leg. Obviously, hypotenuse leg is not going to be in the mixer because these aren't, not right triangles. Anyways, so they put these values in. Now, here's the thing. Oh, the other thing you should know is triangle angle sum theorem, right? If I know two of the angles, I can get the third one because they all add up to 180. So this adds up to 83. So that means this has to be 97. And it's going to be 97 for both because the angles are both there. So that's what we need. First, you need to know what to fill in, if anything, into the diagram that's not there, but that you definitely know. We definitely know that you got to put it in. So you notice we have all the angles now. So something like this, look, we can get angle, side, angle. That's right. Or, angle, angle, side, essentially, too. But basically, what we're saying is all we need is one corresponding side linked up that we know that are equal, and we're good to go, right? So that's how you got to approach it. You got to know these theorems. And then it says EF alone, that doesn't help. That we already knew, so that doesn't help, right? There we go. Look, BC and EF and their corresponding sides. How do I know they're corresponding? Because they're opposite the same angle. And that's going to give it to me. That's going to give me SAS, right? Or I mean, ASA. And then this BAC EDF, no, because that's the same thing of the 97. It doesn't matter. We already know that. Okay, let's go to another example. So this is another one. So it says right triangle ABC. Let's draw it out. Boom. I think that, yeah, B is the right angle. A is 40. And obviously then this is 50. So let's see, C. Okay, so this is not like the proof type, but it's the same idea. So, what can we determine from knowing this? Now, the measure of angle C, obviously, yes, because I already put it in. And that goes back to this puzzle component. Like you get a diagram. They don't tell you everything that you can put in, but fill it in. It took me 2 seconds to think of that, right? So obviously 1 is good to go. So it can't be just 2, can't be neither. So it's either 1 or 1 and 2. And then the length of AB. So this one is like, hey, do we have enough information? Oh yeah, sorry. Oops. See, that was bad. I almost forgot to write that in. Got to write everything into the diagram. So do we have enough information to find AB? Now, I have had students that have been like, well, wait a minute. It's not a special right triangle. So I can't do I don't know. But we do have another tool that on the SAT. What's that tool? Trig, right? So if I call this side X, look what I can do. I can take cosine of 40, which is equal to adjacent over hypotenuse. And look at that. I got an equation that I can solve for X. So yes, I can solve for 2 as well. All right. So that's another interesting one. Here we come back to another, what is sufficient to prove that the triangle is congruent. Again, we got angle, angle. If I have 2 angles, I know the third is 110. Same here. Boom. So all I need is 1 pair of corresponding sides. Again, this is another angle, side, angle situation. Now, this one's interesting because we have 2 options that show sides are equal. This one says that BC is equal to EF. Okay, well, that's obviously the right one because they're corresponding sides because they're both opposite 35. But what about C? AC and DE. AC and DE. Well, these are not corresponding, right? This is opposite 110. This is opposite 35. So that wouldn't, even if they were equal, that wouldn't help us. We need corresponding sides to be equal. Okay, so that's kind of how you do that one. But again, more examples. We see this one. Actually, I will talk about this because this is not congruence, it's similarity. It's different, but still the same. And the similarity theorems we have angle, angle is the most common one. And then we also have, hold on, I have an infographic for this. 1 second. Let me just pop that up here. How can I do it? Wait 1 second. If I go this way, here I'm going to go like this. Triangle, congruent. Here we go. Okay, so here are the similarity theorems, right? We talked about the congruence. So we have angle, angle. And then now this one is side, angle, side. This is what I want to show to you because you might be like, wait a minute, it's side, angle, side for congruence theorem. But it's not side, angle, side like the sides are congruent and the in between angle is equal. It's like the angle's congruent, but the sides are proportionate, okay? So you have 2 sides around that angle that are proportionate. And then side, 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 again, it's not side, side, side of congruence. It's all 3 sides are proportionate, okay? So we come back to this, and let's again put in that information, right? We know that these 2 angles are congruent because they're vertical angles, so you got to know that. And then, so we already have 1 pair of angles. We get another one immediately. We're good to go. So let's see, and we're trying to figure out if we need both of these, one of these, or none of these, or whatever, right? So they first say, hey, what would we say if DE is parallel to HG? If DE is parallel to HG, that's interesting because now we have a transversal coming down. And if we have a transversal coming down, that means this angle is congruent to this angle. And alternate interior angles are congruent. Well, guess what? That's angle, angle. That's sufficient. So 2 is sufficient. Oh, wait. So 2 is definitely sufficient, right? And then let's see. So obviously this one's wrong and this one's wrong. So now the question is 1 sufficient? So assuming that we come back to this, we don't know this is parallel, right? It says length of DE is 1/3. So if this is X, this is 3X. Okay. Now, At this point, we don't know any other angle relationships. We only know that one angle is congruent, and we know that we have one pair of sides is proportionate. But remember, the similarity, we need either two sides or all three sides to be proportionate. So this one's not going to cut it, right? So we just have two, what is it? Two is sufficient. Anyways, so those are your similarity theorems. Make sure you know those as well. Just check. How long are you streaming? I'm going to stream for about an hour, I think is how long this is going to take. Roughly, maybe less. Mean, median, mode questions. We will, I think that's in the, well, yeah, I mean, they're definitely on there, but, you know, mean, median, and mode questions, I didn't flag them because I feel like they've always been sort of on there. So it wasn't something that stood out to me. Like, if you've done enough practice tests, you've seen them, and you're not going to get, like, crazy variations, in my opinion. So again, this is another one, right? I'm not going to go through this one because we just went through another thing. But again, similarity. We're back to the similarity. A, B, C, and E, D, C, whatever, right? And they're giving you some information. You got to figure out which one is not enough to hit one of those theorems, right? And, okay, cool. Now, this one is, I actually only have one example of this. And even though I put it here, I'm not like, I've seen a few of these, not a crazy amount, but I did feel like, wait a minute, they didn't really test on volume of like triangular prisms back in the day on the earlier practice tests. So I wanted to point it out because you may just have forgotten this formula. But anyway, something like this, you know, you just remember in general, the volume of a prism is the area of the base times the height, okay? And so what they're saying is, hey, what is the area of one of the triangular bases? Again, it's base times height is equal to the volume. And that's it. So if you remember that, something like this is not going to be too bad. Divide by 12 and you get a base of 8. Okay? Not crazy complicated, but wanted to point it out. Okay, this one's interesting. Percent increase. I noticed this a few times. Now, it's particularly relevant when you have a value over 100%, because here's what's going to happen. And this is a free response, right? It's a little sneaky. You might look at this and be like, oh, 200% of 300 is 600. There's my answer. Boom, done. But it didn't say what is 200% of 300. It said what is the result of increasing 300 by 200%. So since 200% of 300 is 600, to increase it by this amount, you have to add it to the original. Hence, the answer is 900. So it's very sneaky. Now, if you want a way to think about this, if you get confused, think about it on the test. Be like, hey, wait a minute. Do I just take 200% or do I take it and then add it? Imagine if it said increase by 40%. You wouldn't just take 40% because then you get a smaller value than the original, right? 40% of 100 is 40. That's not an increase. Increase by 40%, it means you take 40%, 40, and add it, and now you're at 140. You see? So that's a way to kind of get around it logically. All right. Graphs of rational functions. These have been popping up lately, and these are kind of interesting. So it's these ones. Now, I'm not saying you should go and do a bunch of practice problems. I'm going to give you some tactics into how to hack them. But something like this is a particularly hard one. Now, it is a calculator section, so you could actually choose a value for k and plug it in and kind of look at the functions. But, you know, another thing to remember is for these rationals, when they zero out on the bottom, that's going to be where you're going to have a vertical asymptote. And it's going to zero out when x equals -1. I could potentially see an asymptote at -1 here. Definitely not for B because the asymptote's at like +1. Same with D. So just like that, I've eliminated it down to A or C. And then, you know, actually, we'll leave that one. I'm really all about plugging and chugging, right? And we have some interesting things here, right? If the main thing is, like, this has a positive y-intercept, this has a negative y-intercept. Okay, well, let's plug in 0 for x and see what we get. So I get k minus 0, which is k, over 1 plus 0, which is 1. I get k. Now, what did it say about k? It said k is a positive constant. So I can't be getting a negative y. If k is the y-intercept, it can't be, you know, down here. So C is out and A is the winner. That's it. So you got to choose some nice values to plug and chug, and then you're going to be good to go, okay? All right. And somebody's saying, how should I study today? Good question. I think joining this stream is good. Maybe if you want to do a practice test or one section or two sections later, that'd be fine. I would just say, don't go crazy today. You don't want to burn yourself out and study late and then have problems sleeping. So make sure to cut it off at a reasonable time, 4 or 5 p.m. If you go a little bit later, it's fine. But then give yourself some downtime to relax, eat something nice, healthy, whatever, and just, let yourself chill out. You want to get good sleep. Okay, here's another example. So again, we can start with that idea of we got a vertical asymptote at -2. B is out. That's got a vertical asymptote at 2, right? But when I say vertical asymptote, just as a reminder, right, it's that invisible boundary where it cannot cross. You sort of see them like not exactly touching that point. These three, might be there. It's hard to tell. This looks like -2-ish, maybe negative. I can't tell exactly, but probably. Okay, and then we need some other points to check, right? Of course, y-intercept would be great to check. Plug in 0, so 0 those out. We get a y-intercept of 8. Definitely not A, right? It's not touching it at 8. Definitely not C. It looks like it's touching it at like 2. This looks like 8. I mean, just like that, I solved it. Did I show crazy expertise of rational functions there? No, but nice little plug and chug saves the day. Okay. Next is unit circle. The reason why I wanted to point this out is just because I hadn't really seen questions just straight up hitting the unit circle like this. And I say the unit circle because 3/4 is in quadrant 2. So it's not as easy to do a conversion and just use a triangle, right? But I want to tell you something. So if you do have the unit circle memorized, you'd be like, oh, cool. 3/4 is out here. Sine of that is going to be, if you remember the coordinate, it's rad2/2. Done. You're out, right? But you may not have it all memorized. You may not have it down. And if you don't, it's fine. Because all you got to do is remember that 3/4, if you convert it to degrees, is 135 degrees, okay? And 135, what's the reference angle to the x-axis? What's, basically meaning, what's the distance when you just bring it down to the x-axis? That's 45 degrees. So what is this really saying? It's saying, what's sine of 45? Oh, that would be like a 45-degree angle in a 45, 90 right triangle, where I know that this is x, x, x rad 2. So sine of this is opposite over hypotenuse. X over x rad 2, cancel, cancel. 1 over rad 2, if you rationalize it, is rad 2 over 2. Boom. So you can still get there. And then the other thing you have to remember if you do it this way is like, wait a minute. I'm in quadrant 2, okay? Because it was originally 135. Is sine positive or negative there? Then you have to go back and remember, oh, yeah. Because sine corresponds with y values, it's definitely positive in the second quadrant. Hence this, not the negative version. But just pointed that out. If you do like the unit circle, maybe you're a little rusty, wouldn't be a bad idea to review it. I could see them doing something like this. Cosine of 5 pi thirds, something like that. So I wouldn't say it's, what I would not do is sit down. If you're totally unfamiliar with the unit circle, sit down and try and memorize it. I wouldn't do that. But if you're pretty good at it already and want to brush up, fair. Okay, here we go. Slopes of radii and tangents, right? Okay, so what am I talking about here? I'm talking about circle radii and tangents to circles. I don't know why, but they've been popping up a lot lately. Here's one example. So they're saying, what point also lies on line T? And we got these 4 different options. It's kind of tough because I don't even have an equation for line T, right? I have a coordinate, but I don't know the slope. But we have something interesting here. They said it's tangent. Well, if I draw on a radius, and that's the main takeaway too. Circle problems, draw on a radius 9 times out of 10, okay? And then you draw on a radius, you're like, wait a minute, that sure looks like a right angle. And it is, because radii are always perpendicular to tangent. Well, I can get the slope of the radii because I have 2 points. It's 1 minus -3, which is 4 over -1 minus 4, which is -3. Oh, it's a slope of -4/3. That means this has a slope of positive 3/4 because it's perpendicular, opposite reciprocal. So I have y equals, let's do point slope. I have y minus -3, which is plus 3, equals 3/4 times x minus 4. And that's an equation of this line. Now I can be like, hey, which one of these actually works with this equation? I think it ends up being C, I'll just show you. And then you plug it in, you get 8 here and 2 here, and you get 5 equal, and then it's, wait, did I do that right? 2, was it 8, 2 or 9, 1? Wait, 5 equals 4. Oh, shoot, wait, I think I made a mistake. Hold on. 4, oh, sorry. I did this wrong. I did the wrong slope. My bad. It wasn't negative 4/3. It was 1 minus negative 3 is 4. Negative 1 minus 4 is negative 5. Sorry, it was negative 4/5. So the slope is 5/4. Excuse me. Yeah, it is 8, 2. And then if you plug in 8, 8 minus 4 is 4 times 5/4 is 5. So it works. That's how you do it. And then I'll show you one more example like this one from a more recent test. It's the same idea, right? Draw it in. And they want this literally the slope of line K. So first calculate the slope of the radii, which is negative 4 minus negative 5, which is negative 4 plus 5, which is 1. And then over negative 5 minus negative 7, negative 5 plus 7, which is 2. So then the slope is negative 2, opposite reciprocal. And it definitely looks negative, so that's also good. Okay, exponential graphs. Now, these are nothing new, but I have been noticing them pop up a lot, and this is one particularly hard version, so I did want to go over this. So look what it does here. It says now this is so sneaky. It doesn't say this is the graph of f of x. This is the graph of f of x minus 1. So now they want the function of f. Okay, so it's very tricky because first, if this is f of x minus 1, if you know your transformations, it's shifted down by 1, which means the real function is going to be up here, shifted up by 1, shifted up by 1, shifted up by 1. So then you could be like, oh, this is the actual function. So you got to catch that, draw it first, then you do your typical plug and chug. So you're like, oh, okay, now I have this. Well, I say I have a y-intercept of 3. Plug in 0 there, don't get 3. 0 there, don't get 3. 0 there, I get 2 to the 0th is 1 plus 1 is 2. That's wrong. But this one, it works. 1 plus 2 to the 0 is 1 plus 2 is 3. Boom, done. Okay, so back to the basics, back to plug and chug. Sum of solutions, these are nothing totally new, but seeing them a lot, so I want to throw it out there. Want to remind you of the shortcut. We're going to go over it again in the formulas too, but the shortcut for the sum of solutions for a quadratic is negative b. So negative b is negative negative 1 over a, which is 1. 1 over 1. Boom, done. Okay. Why does that work? Well, this is actually factorable. You'll notice it's x minus 4, x plus 3. The actual solutions are negative 3 and 4. Look at that. 4 plus negative 3 happens to be 1. It's a little shortcut, okay? It's derived from the quadratic formula. If you add the two solutions of the quadratic together, you get negative b over a. But anyways, 1 is the answer. That's how you do it. Just a reminder. Oh, wait. And was that it? Yeah, there we go. That's it. Okay, so that's it for the prediction section. I hope you guys found that helpful. If you did, click the like button. Appreciate it. And let me see if we got any. Oh, good. Somebody said I'm calming them down. Upcoming gamers. That's what I want to hear. That's what this is all about. Okay? To be calm, to be in the zone by practicing, by working, by going through your paces. And I'm hitting that workout today back and back. You guys are talking about working out. Hey, I'm all about working out. You should do that too. It's very important. Okay. Let's get on to the formulas. All right. Now, I have a video on this. Let me post it in the link so you can watch it later. Hopefully, if you're here, you've seen it because it's one of my biggest videos. But let's see. Math formula Bible. Here. This one. And 60. So here you go. Here's the link. You guys can definitely watch that later as well. But I'm gonna go through it now as well. So here we go. Formulas, right? First formula, you gotta know slope of a line. You take the difference of the y values over the difference of the x values if you have two coordinates. Here's an example. Okay, so it's y1 minus y2. And notice I like to stack the coordinates and subtract down. Okay, so it's very important to do that. So you just don't do it out of order. You don't want to do 2 minus 1 and then 5 minus 7. So we subtract down and we get a final slope of 1/2. And that's how you do it. Slope-intercept form, very, very, very important. Okay, if you put an equation of a line in this format, you can tell that m is the slope and B is your y-intercept, and that's really valuable pieces of information. So in this example, right, if we had a graph, the y-intercept is right there, that red point at 7, and the slope is 2. But remember, it's not just 2, it's 2 over 1. Think about it as a fraction, right? So to get to a new point, you go up 2 and to the right by 1. There you go. Next is point slope form of a line, okay? So if we have point slope form of a line, this is what it is. Y minus y1 equals m times x minus x1, where m is your slope again. But x1 and y1 are coordinates, okay? So here's an example. We got 3 and 4 plugged in for x1 and y1. So what does this mean? This would mean that we would have a line with the coordinate 3, 4. And you can plug in any coordinate on the line, and it will still come out with the right equation. And a slope of 3/2, and that's what we drew there, right? We go up 3 and over 2 to get from one point to the next. So that's the idea. Next, for midpoint formula. We've got the midpoint is found of any 2 points by taking the average of the x values and the average of the y values. So check this out. If we have an example of 8, 4, 6, 7, we add the 8 and the 6 together, right, the x values, and take the average. Then we add the 4 and the 7 together, and we take the average as well. Next, we have the distance formula. Okay, this is not like so important. I really feel like this comes into play, especially when you're trying to calculate the length of a radius. Sometimes if you're given the center and a point on the edge. So that's really the most common way you'll have to use this. But anyways, here it is. It's the square root of the difference of the x value squared plus the difference of the y value squared. So as an example, if we have these two coordinates, right, you're going to do the x values there, 5 minus 1 squared, and the y value is 3 minus 0 squared. That becomes 16 plus 9, which is 25. Square root of 25 is 5. Boom. That's how you do it. Then we have length of an arc of a circle. All right. Now, what you might notice is 2 pi r. What is that? That's circumference of a circle. And it's no surprise because length of an arc is a piece of the circumference. So you're taking a circumference and then you're taking the fraction of the central angle n out of 360. Why out of 360? Because that's the total amount of degrees. Now, if this is in radians and n is in radians, you do n divided by what? By 2 pi, because 2 pi is the amount of radians going all the way around. Okay. Next, we have area of a sector. Area of a sector, notice pi r squared does not look familiar. That's the area of a circle, and then we multiply that again by that same fraction. Central angle out of 360 or central angle out of 2 pi. Next, we have the quadratic formula, which we talked about earlier. So hopefully you guys have this memorized and you know that, that's where you get those constant values from your standard quadratic equation, okay? And then you plug and chug and do your thing. I got a song about it. If you're having trouble memorizing it today, actually, let me post that here. Quadratic formula song, scalar. Here it is. This is in one of my old ones. Here. Let me share this with you guys. Boom. Somebody is asking if anyone knows if the digital SAT, the level of the real examiner, those are the blue book practices. So I think it's a little, okay, I'll put it like this. I can't say for sure, right? It's a little up for debate. It's a new test. We're gonna have to see once some of these start coming out, or people like me are able to actually take these tests. But what I mean, my assumption is generally the College Board's pretty good at giving you like official practice that's very, very representative of the real thing. So my assumption is the digital is going to look very similar to like the blue book test I did yesterday. And remember, module 2, if you saw it, you might be like, dang, that was hard. Well, that was the module that I went to after getting everything right in module 1. So it's adaptive. So if you do really well in module 1, yeah, it's going to be hard like that. But that's what you hopefully want to see that, because it means you're doing well. All right, let me get some water. All right, here we go. Next is SOHCAHTOA. This is your trig stuff, right? And we definitely want to know SOHCAHTOA. And this is just basically the acronym to remember. Sine is equal to opposite over hypotenuse, right? So we say sine of A is equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse. And tangent is equal to opposite over adjacent, right? And that's why it's color-coded. So again, this is in the... Oh, by the way, I posted this infographic as an image on the community page. So you can also check that out there. It has all these formulas and a nice little infographic if that's easier for you guys. Next, we have probability. That's just the number of favorable outcomes over the total number of outcomes, okay? Hey, you have, what's your chances of drawing a king out of a deck of cards? We got 4 kings out of 52 cards. So your probability is 4 out of 52, right? You could reduce that 1 out of 13, but that's the idea. Circle. Somebody is asking about the circle equation. Here we go. This is the equation. X minus h squared plus y minus k squared equals r squared. And h and k are your center coordinates, okay? And r, so remember, whatever value you have on the right side, you take the square root of that, and that's your radius. That's r, all right? So in this example, you'd have a center at positive 2, comma negative 5, right? It's the opposite of each of those. And a radius of 6. Now, one thing that has been shown up too a lot, but this is kind of throughout, is the harder versions of these questions are where they ask you what the radius is, but it's not in standard form. So if you've forgotten how to do that, you need to watch my critical concept videos. Let me post that as well, actually. Okay, 1 second. Let's go here. You need to watch, which one was it? I think it's this.
Those 2?
Ah, look at this. It goes right to the thing. That's so crazy. So this is literally the part right here. So if you want to timestamp it, here, actually, let me see if I can timestamp this.
And the radius for the...
Yeah, perfect. All right, so I'm going to timestamp this for you guys. This is how to do a circle equation. I'm not going to do it here, but you can watch that later if this is something you want to brush up on, where it's not like, look how it starts, right? It starts like this. That's not in standard form. So we got to get it to standard form, you see, and then, it shows that process. Okay, back to this. Next is exponential growth or exponential equations, right? And with these, we have our general idea of this, of this format. And A is the initial value, R is your growth rate, right, as a decimal format of a percent. And then T is the time, usually the number of years. So as an example, if we're talking about growth, we say, hey, we start with $200 and it's growing at 13% per year. And we want to know how much money you'll have in 3 years. So you plug and chug 200 plus 1 times 1 plus, 0.13 to the third. And then we have exponential decay. This is when we're losing value. But it's the same idea. Now you're just minusing that percent. But everything else is the same. So now it's 1 minus 0.09. So you'll end up with 0.91. So the other thing you'll see a lot on the SAT is you'll see like the decay. It's not going to say 1 minus 0.09. It'll just say 0.91. But that is representative of whatever of that percent decrease, based on the difference to 100. Okay? Somebody wants the link to the formula sheet. Here, I posted it. I think I posted on Instagram too. Hold on. Okay, let's go here. Here's our Instagram page. Yeah. So here's the Instagram link if you want. So I also post this on YouTube, but here you go. Okay. Let's go to next, vertex of a parabola. Here we go. So vertex of a parabola, this is a huge formula, very important. And if you need it, the x value is negative b over 2a. Simple, right? This is in standard form. You just right away, oh, there's my x value. You want the y value of the vertex? Plug that in. Solve. That's it. Okay. Vertex form. This is when you're in standard form, you put it in this form, okay? And when it's in this format, you can tell what the vertex of a parabola is. It's h, comma, k. So you notice the h, you flip the sign. The k, you leave it as is. By the way, the a value indicates whether it goes up or down based on the sign, right? If it's positive, it's opening up. If it's negative, it's opening down like this, right? Pythagorean theorem, this is actually given on the test, but we'll just say it anyways because it's so important. A squared plus b squared equals c squared when a and b are the legs, meaning the smaller two sides that make that nice right angle, and c is the hypotenuse. That's that. Boom. Distance equals rate times time. You might think this is a silly formula because it's literally that. Distance equals rate times time, but it's very helpful for different like rate and distance problems and stuff like that. So just remember it, and sometimes you'll be surprised. It definitely helps me out. Just be like, wait, how do I put this in a framework? Oh, use that formula. Sine and cosine. Now we already gone over the basics of trig, SOHCAHTOA. This is a special relationship that the College Board loves to test on, which is that sine of x equals cosine of 90 minus x, and vice versa. Cosine of x equals sine of 90 minus x. So as long as you're taking sine of an angle and cosine of its complement, they're equivalent, aka sine of 10 equals cosine of the complement, which is 80. Again, complements are angles that add to 90. Also, sine of 20 equals cosine of 70, and on and on and on. You see? So that relationship exists throughout. They love to test this. Okay, so just be on the lookout for this relationship. 18, sum of solutions. We did go over that in another example, but the sum of solutions of any quadratic in the standard form are equal to negative b over a. Nice and simple. It's much easier than solving and then adding the solutions, right? You just be like, oh, they want the sum of the solutions, negative b over a. Done. Out. Boom. Okay. And in this example, right, we got this quadratic equal to 0. The sum of the solutions are negative 7 over 2. That's it. That's how we do it. Okay. Discriminant of a quadratic, extremely important when we're talking about number of solutions. Hey, how many solutions does a quadratic have? 0, 1, or 2? That's it. Can't have infinite. Can't have anything else. You can have 0, 1, or 2. And it's based on the discriminant, which is b squared minus 4ac. Might look familiar because it's the component under the radical in the quadratic formula. So if this is a negative, okay, so in this example here, we get 9 minus, 40, which is negative 31. It doesn't matter. It's negative. We get no solutions. Okay, and that makes sense because if you think back to the quadratic, if you got a negative under the radical, can't take a square root of a negative. So that's why it's not a real solution, because you're taking the square root of a negative. But if it's 0, okay, something like this, that means you have one solution. And last but not least, if it's positive, then that's your normal situation. You have two real solutions, okay? Area of an equilateral triangle. This is a little bit of not so commonly tested, and you can get around it by deriving the formula using special right triangles, but not a bad one to have in the back of your pocket. And this is the formula. If you have an equilateral triangle, it's s squared times rad 3 over 4. So just as an example, if we have all sides of 1, you take 1 squared, which is 1, times rad 3 over 4. If it's 2, you take 2 squared, which is 4, times rad 3 over 4. That would, of course, cancel out to rad 3, but I left it like that. And here would be 3 squared times rad 3 over 4, which is 9 rad 3 over 4. Pythagorean triples, okay, these are very, very, very useful, and there's only going to be 4 that are going to likely pop up. I haven't seen really any other ones in these, so these are the ones that are money. And it's great because if you see that a triangle is a 3 and a 4, you know the other side is 5. You don't even have to use Pythagorean's theorem. Same with 5 and 13. Oh, the other side is 12. Same with, So if you have these ones memorized, it's going to make it easy. And if you have them memorized, they love to throw out multiples of these. So, for example, they may not put a 3, 4, 5, but they may put a 6, 8, 10. Very common. Also, like, any of those 4 versions. 5, 12, 13, here are some other multiples to think of. Same with the other 2. So just keep that in the back of your mind. Now, am I saying you, have to memorize all of these? No, I'm just telling you this to be aware. Like, oh, wait a minute, 16 and 30, that seems familiar. Oh, the other side would be 34, right? Because you can say, hey, it's just double 8, 15, 17. So perpendicular slope, we have talked about this, but if you know that the slope of a line is something, the perpendicular slope is the opposite reciprocal, negative b over a. By the way, if 2 lines are parallel, the slopes are the exact same. So if it's A over B, parallel slope is also A over B. Boom, done. And in this one here, we have a slope of 2/3. The perpendicular slope would be negative 3 over 2, okay? Different y-intercepts, they can be the same. It doesn't matter. I just put in a random 5 and an 8, but that's the idea. All right, last one. Sum of angles in a polygon, okay? So whatever polygon you have, the sum of all the angles is going to be the number of sides minus 2 times 180. Now, you know that this makes sense because in a triangle, we all know that there are 3 sides. And we all know that it's 180 degrees. That's something that you got to know, at this point, right? The triangle angle sum theorem. So you can always verify, like, hey, wait, is this the right formula? Because you're like, if I plug in 3 to this, I get 180, right? And that's a triangle. 3 minus 2 times 180 is 180. And most people know that a square has 360 degrees. So you can also be like, all right, does the same formula work for 4? Well, yes, it does. 4 minus 2 times 180 is 360. And then you can apply that to any shape, right? Here's a pentagon, so it would be 5 minus 2, which means all the angles add up to 540. Okay? Now, is this like a crazy tested concept on the SAT? No. But occasionally it can come up and can be helpful for different shapes if you can't remember, hey, what is the angle sum for these guys? Okay. That's it. That's a wrap. That's the entire presentation. So I'm going to take a look at the questions now and see if we can answer some of these. So let's see here, the little Q&A section. Someone I know told me how to know surface area of equilateral triangle. They asked it, by the way. Okay. May 2020, no calc 14 said it was A. Oh, so if I said a wrong answer, I probably just watch to the end of the video, because what I do in the videos is I check. So this is for Akhilesh. I check the answers at the end, and if I do make a mistake, I go back and I explain it. So it's in there. Just check it out. Is Khan Academy harder than the actual test? Yeah, if you're talking about the practice bank, yeah. If we're talking about level 3 and 4, usually they are definitely harder. Khan Academy overrated. It's still pretty good. I mean, it's free and it's pretty darn good in a lot of ways. Could be, it could be better. Anything can be better, Let's see. I mean, somebody asked about doing practice test 9 in preparation for the digital SAT tomorrow. I would say if you haven't hit all the digital practice SATs from the Blue Book, that would start there first. Then I would say I would lean more towards doing the more recent release test than practice test 9. But yeah, practice test 9 is obviously in the mix as one of them. Prediction for standard deviations. Oh, good question. Yeah, I mean, they'll definitely be on there. Probably one question, and not definitely be on there. 50-50. You might have one question or none. But it's always the same. It's always like you're looking at the spread of the data. More spread out, bigger standard deviation. More tightly packed together, smaller. That's all you need to know. Oh, I know what you're, Robo, you're asking about where it puts two root problems against each other and asks what, okay. You're talking about a problem that is on, I know exactly what you're talking about. Let me pop one up here. And I'll show you. Yeah, these are tough ones that I think it's March 2023 where that was. Let me see. Sorry, I'm just looking on on the side screen. It was if you remember the practice test that's from, tell me. But I'm looking at March 2023. I want to say it's nope, not this one. Maybe it's May. Hold on, let me see May. I feel like it was on the no calculator section, right? Darn it, I can't find. I know exactly what you're talking about. Hold on. Let me see if Robo, did you tell me where that problem is? I mean, look, but I know the type of problem he's talking about is where they're saying like if x to the a power equals the square root of y or something like that. But the first step is always to literally make an equation, set them equal to each other, and then use algebra to kind of figure it out. But like if you tell me where that problem is that you're talking about, I'll pull it up here and I'll solve it for you. I just can't remember. Vertex of a parabola. I showed you that, Mahir. It's back here. I'll go back to it. Hold on. Oh, man, it's going to take forever. Wait. Let me do it like this. I think I can go 49. I can't even see them. Wait. Here, let's get out of this mode. If I go like this. You said vertex. Here's vertex of a parabola. Negative b over 2a. That's the x value. Margin of error. Good question. I did see one in the 2023s, and I do see them. I would also say 50-50. That'll show up. But they're not bad. Remember what margin of error is. If they're like, hey, we calculated a mean of 10 with a margin of error of 2. You just got to remember that the mean could be anywhere from 8 to 12. 2 less and 2 greater. That's really it. And to shrink the margin of error, you need to increase sample size. That's another one they like to test on. But that's definitely 50-50 because they're not on every test. Share some of the questions of quadratic where and it gets confusing. I feel like I went over that earlier, so maybe you might want to rewind because those are I did a bunch of like the tough quadratic ones that keep showing up. Can you give a bulletproof guide on how to solve fractions to radical equations? Yeah, you know what? I can kind of do that. So that's static Hershey. Let me kind of give you an idea. Let me see if I can find something here with this one. Okay, this is a pretty tough one. I think this will be a good example. Let's do this. And when you say bulletproof, I mean, look, there's going to be some variation in terms of, how the problem is presented. But I'll do it like this, okay? Generally, you see this, and you should be thinking, I should probably turn these into rational exponents, okay? And then the other thing is so if it's in radical, you probably want to go rational and vice versa. That's just like generally. And then you also ideally should try to be thinking like same base. That's always going to be something. And I look at 32 and 64 right off the bat, and I'm like, oh, yeah, like they both can be written as powers of 2. So watch what I'm going to do. First, I'm going to say 32 is 2 to the 5th, and we still have the square root of that. And then this one is the 5th root of 64. 64 is 2 to the 6th, right? You can figure that out by just multiplying 2 times 2 times 2 times 2, whatever, okay? And then you want to simplify. So if I have 2 to the 5th, that becomes 2 to the 4th times 2. So this is a way we can simplify radicals. I'm trying to find perfect squares here, which that is. Here I need to find perfect fifths, which is 2 to the 5th. So I can make it 2 times 2 to the 5th, right? Because you multiply 2 times 2 to the 5th, you get 2 to the 6th. Now I can simplify. Square root of that is 2 to the 2nd. And I can simplify that. Square root of that is just 2. And then now we use what I said. We take this into rational exponents, right? So these 2's multiply, or sorry, that's 2 times, that's 2 squared, that's 4. So 4 times 2 is 8 on the outside. And then this is, the square root is again 2 to the 1/2. And the 5th root is 2 to the 1/5. Again, that's the power, which is 1, over the index, which is 5. Here it would be 2. Well, that 2 is actually being squared, but when there's no number, it's 2. And then we use our exponent rules. We add the exponents. 1/2 plus 1/5. That's 5/10 plus 2/10. That's 7/10. So then it's 8 times 2 to the 7/10. And that would be a great answer. Now, they turned it back into radical format, but now when you're here, you're golden because you know that to convert it back, it's just the top number is the power, the bottom number is the radical, and then it's that times 8, and that's it. That's kind of how I would give you my, you ask for like a bulletproof guide. Like that's the gist of it. Those are the key things. Get the same base if you can. if it's in radical format, you're probably going to have to go rational. You're going to want to simplify to whatever degree you can, etc. Okay. It's on October 2022. Lloyd Brown. Oh, you're talking about, I know what you're talking about. You're talking about that problem. Okay. Thank you, Lloyd Brown. Let me find it. I think it's on the no calculator section. 1 second. Wait a minute. Lloyd, what question was it? I don't see it on the no. Hold on. Let me check the calculator section. Because I remember it was on the free response, right? I found it. All right. Yeah, thank you, Lloyd. Appreciate it. Okay. Yeah, I knew it was a recent test. Actually, I took this test, for real. Like, I went to the test center and took it. I remember. Okay, so it says two numbers A and B are each greater than 0, whatever. And so this is what I was saying before. Like, write it out as an equation. And then it says 4 times the square root of A is equal to 9 times the cubic root of B. Okay? And then it says if A equals 2/3 for, okay, so this one is crazy, right? It's like so many things. Then it says if A equals 2/3, so goodbye, A, for what value of X is A to the X equal to B? Yowzers, okay? And then if A equals 2/3, then it says, and then again, X, what does it say? A is 2/3. So we want 2/3 to what power is B? This is wild. Okay, so basically what we're gonna have to do is let me get my bearings on this one. Oh yeah, we have to isolate B. That's right. Okay, so we have this equation. It's just basically we have a system of equations. We need to isolate B, and then we need to sub it back in here, and then we can solve. So, what are we gonna do? Oh, first I got to get rid of the 9. So I'm gonna divide by 9. Sorry, and I get 4/9 times square root of 2/3. And then that equals the cube root of B. And then I'm going to cube both sides because I need to get that out, right? So that cancels that. And then this is, what does this become? This is going to become pretty big, huh? This is going to be, oh, wait a minute. There's a little thing you can do here to make life easier. So you notice that eventually this is going to be 2/3 to some power. Well, 4/9 is 2/3 to the second power. Okay, and this goes back to that idea of trying to maybe convert radical to rational exponents. And then this is the square root. Well, again, and this goes back to the same idea of getting the same base. 2/3 is also to the square root is to the 1/2. Well, look at this. They're multiplying each other. Now I can add the exponents. So it becomes 2/3 to the 2 plus 1/2 is 2.5 or 5/2. And then it's to the third power, right? So then 2/3, and then you multiply that in. So then it's B equals 2/3 to the 15/2. And now if I plug it in, look at that. 2/3 to the X equals 2/3 to the 15/2. I got my answer. 15/2. That's it. Okay, I hope that helped. So Alpha asked, how does adding and removing a number to the data set values affect mean, median, and range? So it depends, okay? You have to do the analysis. Now, you know how to calculate mean, right? So if you're not sure how it changes it, calculate the means with the new value. But in general, if you add a really big value that's bigger than the current mean, it's going to increase the mean. You add a value that's smaller than the current mean, you're going to decrease the mean. You add a value that's equal to the mean, it's not going to change. Median, you've got to take a look at the numbers, right? I can't just say every time it's going to do this. It depends on if it's big, if it's small, where it places in the, and how it shifts the numbers. So really, I wouldn't say how does it change it. I would say calculate it. Look at the new value, add it in, calculate the new mean. Has it changed? Has it stayed the same? Range, same thing. If you're adding a new value that's either going to become the new biggest or the new smallest, yeah, it's going to change the range. Otherwise, it's not, right? So know those definitions. Yeah, triangle similarity. I went over that earlier as well. So the gist of it is this. If you have two triangles, you have the theorems, right? The most commonly tested is angle. So if you know two angles in a triangle are congruent, they're similar. The other way is if you have one angle, but then the sides around it are proportionate. Like if I can show that AC is proportionate to XZ in the same way that AB is proportionate to XY, that's enough. Last but not least, if you can show every pair of sides is proportionate, right? So it's all like a 1/2 ratio, right? 1 to 2, 2 to 4, 2 to 4. I'm just making that up. Then it's also similar. That's the gist of it. Lloyd Brown. Yeah, that's a good way to remember it. Okay, guys. Can you also do log? You don't need to know logs for the SAT, Lloyd. That's only for the ACT. Now, can you use logs occasionally? Yes. But watch my walkthroughs, dude. I've done so many of them. I never use logs, not on SATs. You don't need them, okay? Guys, my voice is super tired, and we're kind of at the end of time. So we got an hour. That's a lot of talking for me. I hope you guys found this helpful. It was so great to see so many of you on here. I know you must be serious. I know you must be working hard, and I wish you all the best. These are always my favorite streams to do because we get such a big group of people that are hungry, that are motivated, that are working hard, and I'm all about working hard and, just doing my best every day, and I can tell you guys are doing the same, and that's what it's about. I do want to say a couple words, too. It's like, it's good that you go into these situations that are important thinking you're striving for the best score you can get, because that's going to help you in college. It's going to help you financially. It's going to be great. But I want you to remember something that's really, really important, and I think something that's helped me in my business and in my life to be happy and feel content is just the process of putting in everything, regardless of the result, right? I think it gets twisted sometimes on these tests because we're so result-oriented. But really the biggest takeaway from this process is learning how to put in the work and put in the effort, pay attention, really think through, take some ownership, take some responsibility, put in the hard work. That process is more valuable than the outcome, okay? Because learning how to do that is what you're going to take with you going forward in whatever you do after this. And even if you don't reach the exact pinnacle of what you think you're capable of on this test, that learning that process is the real result. And that's what's going to be the differentiator later on in life when you try different things and you really put, are you going to put in a full effort or an 80% effort? And then that full effort is what's going to distinguish you from everybody else. So if you're here, my suspicion is you're going to be one of those full effort people. You're going to feel content. You're going to feel happy with what you've accomplished and feel good about everything you're doing. And that's what it's all about, right? Feel level of satisfaction and do your thing. So anyways, that's a little aside. But that's it, guys. Somebody's named Bob Vance Refrigeration. What a great name. No, I don't do this. I won't share the slides, but I shared that infographic, or you can go to my Instagram and check it out. It's got all the formulas, so you can see it there. But anyways, that's it, guys. Thank you so much for joining. This has been a blast. I hope you guys have found it helpful. If you did, make sure to click that like button if you haven't done so yet. We really appreciate it. Helps a great deal. And if you guys have any questions, hit me up. Leave a comment in the comment section. Subscribe if you haven't done so yet. Hit the notification bell as well, and we're going to keep it coming. And by the way, not to mention, we have this huge series on OpenStax coming out. Everything you need to know for Algebra 2 and Trig. It's almost up. It's almost done. So you should check that out. All free. And that's that. Thank you guys so much for joining. Best of luck Saturday, and I will see you in the next video. Take it easy.